In this video, we're going to talk about the derivative, an introduction to it. So we're going to build up to it with a little bit of review. So the first thing we're going to do is graph f of x equals to 3x squared, and then plot the 2 points for x equals 1 and x equals 2, and then connect them with that secant line. So we're going to put a 1 here and a 2. So that's f of 1, that's f of 2, and if we plug in 1, we get 3, and if we plug in 2, we get 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first one's at 3, second one's at 12, and that would be our secant line. So let's connect it with our parabola. So from 0, 0, it would go up, come out a little bit, and then come back that way. So remember, this is our secant line right there. It goes all the way through 2 points, just like that. All right, what we're going to do now is find the slope of that line. So the slope is y2 minus y1 over x2 minus x1. And in this case, that would be f of 2 minus f of 1, not x, 1, with 2 take away 1. Those are our x's. So remember, this point is 2, 12, and this point is 1, 3. So plugging those in, we get 12 take away 3, 2 minus 1. It's 9 over 1, so our slope is 9. All right, so now we're going to do it another way. We're going to create it using the difference quotient and then use it to find these 2 points. So if you remember, our difference quotient is f of x plus h minus f of x all over h. It's our slope formula. So we need to first find f of x plus h. And so plugging that in, we would get 3 parentheses x plus h squared. I'm just using our f of x here equals 3x squared. And so that would be 3x squared plus 2xh plus h squared, just like before in our difference quotients, which gives us 3x squared plus 6xh plus 3h squared. And then now we do our f of x plus h minus f of x. That's the second part, the top. And so all we're doing is subtracting that 3x squared from it. So that'll just get crossed off. And we end up with 6xh plus 3h squared all over h, all over h. And so that's 6x plus 3h. Now, if you remember, our h is the denominator. And so our h here is x2 minus x1. It's the difference between them. It's our change in x. That's our h. And so that would be 2 take away 1, which is, so if I take those points, and so what's happening here is we have our graph with our secant, and our x here is 1. Our h here is 1 because that's 2, right? So what it means is this is our starting point 1. Our x here is 1. And we're going 1 unit away to get to 2. So if we plug that in, it's 6 times 1 plus 3 times 1 is equal to 9. And you can see it's the same slope that we have above. So the difference quotient is another way of finding the slope. If you have a formula, it's just saying from what point do you want to start, and then how far do you want to go away. So it looks like this in Desmos. So you can see here our x is 1, and we are 1 unit away. And so that's x is 1, h is 1, so the slope of this line is 9. It's up 9 over 1. And what we're going to be doing in the next part is it wants us to find the instantaneous. So that means to find the derivative. We want that slope of the tangent line. That is our derivative. So if we take our h, and if you notice I'm making the h smaller and smaller, that just means the distance between the 2 points is getting smaller. Our x is still 1. And as it gets smaller and smaller, it eventually becomes our tangent line. So if we want to find the slope of the tangent, our derivative, we just make h approach 0. Now it can't be 0 because that would only be 1 point. We have to have 2 points to find the slope of the line using our slope formula. So what we're going to do is the limit as h approaches 0. So if we go back over here, we want to change this into our tangent line, our slope of our tangent line. So the slope of our tangent, our instantaneous rate of change, is the limit as h approaches 0 of this. Now our x here is 1, because what we're approaching is the 1. We're starting here at 1. Our parabola goes like this, and that's our tangent. So our x here is 1, our h is approaching 0, and our secant is becoming our tangent. And so if we plug that in, this approaches 0, and you're left with 6. So the slope of this line at 1 is 6. So it'll be up 6 and then over 1. And you can see that we're at 3. And so if I go over here to 2, down here, come on, you can do it. It's 9, okay? So from 9, take away 3, that would be up 6 over 1. That is our slope. And so this is the process that we use to find the slope of our tangent. It's going to be a lot cleaner than what we're doing. This is an intro, but you're basically finding the secant line, and you're using the slope formula, or we can use difference quotient. Difference quotient is the favored form. And then we're taking the limit as h approaches 0, that distance between them, and that's giving us our instantaneous. So if we want the secant, or the average rate of change, then we just do slope. And if we want to find the instantaneous rate of change, or the tangent, then we take the limit. So slope of the secant line through PQ would be our difference quotient. So f of x plus h, and I'm using generic here, minus f of x over h. So if you have 2 points, P and Q, the difference quotient will give you that slope. This is obviously f of x, and this would be f of x plus h. So our P here is representing x, and our Q is representing x plus h. So if we have the slope of the tangent line, that would just be taking the limit as h approaches 0, that distance between them, and you get the slope of the tangent. So you're basically starting with a secant, throwing a limit in front of it, and there's your answer. All right, so these are our notations here, right here. So the slope of our tangent is f prime of x. It's another way of writing it. And it's the limit as h approaches 0 of f of x plus h minus f of x, all over h. We can also do this. We can say that our x is approaching a, and that would give us the derivative at a. But again, all we're doing is taking that secant line, and you can kind of just think about pushing it. We're just taking and pushing it all the way back to create the tangent. These two are backwards. So that one's 3 units away, that's 2 units away. And so if you push it 2 units, eventually it becomes the tangent. And that h right here is approaching 0. And that's it. So in the next video, we'll do some examples.